Today we're going to focus on Trimline development, which is a free add-on functions in AnsysForm. I'm going to import some files here, so I will go import curve. I'm going to bring in the initial blank line, and I'll also bring in the target line. Let's import the product line first. So what we like to do is we need to make sure this initial blank line match the final shape of the product. So the final shape, the product, we call it target line. So the target line should be the middle surface of this product. I think I have them here already. So this is the target line. So as you can tell, target line is in between, in the middle of the surfaces. So basically we need to optimize this outline blank and then match the final product line. First we have to set up the draw. To set up draw, in this case I already have all the mesh files, so I'm not starting from the surface, I'm starting from the mesh. Importing mesh is right here, down here, under miscellaneous. We go import the blank mesh. That's our blank mesh, and then we'll continue import the tool mesh. So we have the tool, or the tool and the blank mesh here. And next step is we just go to blank, and the blank, we need to go to process first, make sure the operation is draw. Yep, so we have the operation draw, then we go to blank. We select the blank by mesh, not by curve anymore, by mesh. So we know the blank mesh is this green one, so we go pick that. Okay, next step, we select material. In this case, we have the material from the previous simulation already, so we go open material file, and the material file is right here. Open that, then we have the material here. FLD is finished, so we go finish, save and assign. Blank thickness is 1 mil, and this is the rolling direction in the X direction. So from there, we can move to operation. And the operation, we need to define the draw, which is single action draw. That's good. So we define die, select. Now we can just go isometric view. This should be our die. Finder is that one. Good, apply, close, and punch is that. So then next step is, this is a standard template. We have 2 stages for single action, closing stage, and then draw stage, die, travel all the way to home. And we do have to define this option. This option basically shows the mesh you bring in is already offsetted, or you need to offset inside the software. We call them invisible offset. So our case is already offset. Apply, close. Then we're pretty much done. We can check the animation, and this is the motion. Okay, we can go back, and for trimline development, we have to do 2 things. First, we need to have a trim station, otherwise there's no trim line to be optimized. In our case, we're going to trim in the first stage. So for the first stage, you cannot call it as a trim. You have to call it as blanking. So what we do is we go back to this operation, basically go back to process operation, add 1 stage, and this stage we're going to add at the first, so we need to move up this stage and change this to blanking. So blanking is the first operation. Trim cannot be first. Okay, then we go to then we have first blanking and draw. Then we go to operation. So this is on operation 505, which is the blanking operation. So for the blanking operation, we need to define which area to keep. Pick one node, we can just pick in the middle of the part. And the trim line. So for trim line, we can say add or pick. I believe our trim line is this. It's the original blank. Okay, so we have the trim line. Now we can go to advanced. Advanced will say no advanced setting for normal forming. This means we need to select something somewhere else. So in this case, actually you have to go to process. I guess process, under process advanced, you have to select trim development. Then we go to advanced. Right here is the trim operation. The trim optimization. We have to have select the target line. The trim line is here already. Target line is this line, is the line we showed earlier. And then we have to select which line you're going to develop. We're going to develop this one. So we're going to say, click on it so it's green. Then you're done. You can go to runner. Where did I get that? Should be okay. And start. And you can tell the default they set 2 iterations to optimize the trim line within the tolerance. I think default tolerance is 0.5, and we can go from there. Okay, the simulation takes about 3 minutes in this case. You can tell iteration 1 is already within the tolerance. So let's go check the result. So to check the result, we need to go back, close here, and right here back to the trim line. So we go view result. And this shows you the initial iteration, how far from the trim line. You can tell this is within the tolerance, positive, negative, is pretty far away. And then let's check the iteration 1. And that's the target line comparison. It's within the tolerance. But where is the trim line? It's right here. So if I turn off the blank, you can see it better. So the red one is the developed trim line, and the blue line is the original trim line the user guessed in the beginning. As you can tell, for 3 minutes, you can get a very accurate trim line for your product. Thank you.